So now what we're going to talk about is a GE Magneblast breaker, and these things are old tanks. So each one of these videos, we've kind of been showcasing a different thing about differences between the manuals and the NETA books. So what we want to talk about here is going to be minimum voltage coil pickups, and then we're also going to talk about electrical diagrams and how to do the pinouts, and maybe a couple little tricks along with those. So we're going to be looking at the GE Magneblast circuit breaker right here, and they're all pretty much about the same. What we're really looking for is the 4160 volt version of it. And these things, this is a picture off of the front cover, and then right here is a picture from the internet of what one of these guys can look like. They are absolute monsters and tanks. Okay, do not try to lift these. They are just heavy, and those arc chutes are big. And yeah, I know they're a pain to take off. So this is what we're looking at right here, and there are many different GE manuals. Okay, so it's important. GE is usually pretty good about the front cover stamping a manual number. And you can see that right here is the manual number up in the top right, and it tells you that it supersedes the old one. So this is the GE Magneblast, and then let's go ahead and look at the MTS. So inside the MTS, we were already talking about a lot of the visual mechanical checks that we have to do, and sometimes these are optionals. Operator analysis, first check, trip check, and then cleaning the unit, perform as found tests. That's an optional as an as found. Still cleaning to the unit is required, right? That's still required. Expect the arc shoots. That's very important. A lot of times critters like to get inside of these things. And then it's a very good place for a fireball when one's going to happen, because that's it's an arc extinguishing thing. And you put paper or dust and debris in there, and then it catches fire, and then it's going to be a problem. So it's always important to clean those out. Then there's going to be a lot of other checks in here, and I want to highlight one on the visual mechanical, and that's going to be a puffer operation. All air circuit breakers and even some contactors are going to have a puffer operation on them. And what that is, it basically is supposed to blow the arc into the arc chutes. Okay. And it's very important that you check this. If you don't, then it's not going to extinguish the arc in the way that it's designed. So after that, we've got a lot more checks to do. And we talked about this before. Insulation resistance is typically going to be like a dielectric. That's pretty standard for a lot of the older circuit breakers. Contact resistance might not be performed, and it might be a millivolt drop check, okay? Or it might just be pressure tests and torque checks. So you just have to follow the manual for that one. That's not what we're going to get on here. What I want to get on here is minimum voltage coil pickups. That's what we're going to kind of focus on this one. So as we scroll down through this manual, what you'll see is here are your voltage ratings that you might run into. Closing operation is the next page. And so as you go through this, what you will see is here is the page for your close and trip coil ranges. Okay, so if it has a 48 volt DC coil on it, and that's what it says that the closing coil is supposed to be, it should be closing anywhere from 34 to 50 volts. Now, the way that these things operate is it might be much lower than this, and a new coil is almost always going to be much lower than the rated voltage. The rated voltage is usually somewhere around the maximum where, hey, we're not going to give it anymore. Okay, so it needs to operate. And you can see right here, pretty much all of these, the upper limit of the voltage for all of these is going to be somewhere near the nominal voltage range. Okay, we don't look, if we got 220 volts DC on that system, uh, the maximum that closed coil should operate is 230 and 250 for the trip coil. Okay, like we can't provide any more than 220, so we're hoping that it operates effectively at this voltage range. Okay, in all honesty, you might just want to replace it once it gets to the nominal voltage. They're almost always going to start off brand new. 96 volts is about where it might start picking up. Okay, so just be aware that much lower is okay. It's not a bad thing. We're trying to figure out how that is. You're going to jog it up kind of like the instantaneous test of a circuit breaker. When you're doing primary injection, you're just going to bump your voltage on, off, on, off, on, off, and eventually it should ping and trip, right? Or ping and close. And so you're going to record the voltage at which it operated at. That would be more like the power system's going to operate. If you try to ramp it up continuously, then the system's not going to operate like that. So I wouldn't run your coil like that. But this is exactly where the voltage ranges that you need and your criteria for assessment. Okay, so that's one of them. The next thing I want to go over, as you can see right here, is the drawing. And so inside this drawing, what we don't have on this, and the Magneblasts are pretty bad about this, is not identifying what pin is what. Look, I mean, it says, hey, here's where everything connects, right? And you're like, okay, cool, but I don't know what that means, right? So how do you figure that out? Well, I'm going to show you a cool little trick. So a lot of these older circuit breakers, right, were replaced, and when they were replaced with newer models, right, and some of them are vacuum style newer models, and so find a revision, right? They were built to replace them directly. Okay, so here is another manual. And you can see that we start to get a little bit more out of this. Okay, so we've got an AC or a DC circuit. This is still a Magneblast, right? It says it right here at the top left. Still a Magneblast type AM. And so you can see an AM stands for air magnetic. So you see you have a little bit more on this one. That's cool. But how about we go to a newer, and I'm going to scroll all the way up. This is intended to be a power vac uh, Frankenstein to replace a Magneblast. Okay, you can see this is a vertical racking in. You can see right here, I'm going to zoom in on this one. You've got your pinout that looks just like the Magneblast pinout. Look, right here's your air Magneblast. There's your pinout right here. Okay, that thing is, it's really nice and handy to have it right there in front of you, but it's a lot of people have a hard time trying to figure out what are the pins. Okay, so let's go all the way down to those drawings that I found you. And here you can see there's your pins, okay? Um, when we get to the drawing, like I said, this is supposed to be a remake or kind of like a Frankenstein of, let's replace this with a newer, updated vacuum style circuit breaker that will fit in the cell just like this old one, okay? So when we zoom in, what we'll see on this is, oh, look, there's your pinout. And what's cool about this, it tells you where your pins are. Now, this is another GE manual, right? So this is GE and GE, right? It says GE right here. Okay. So this is GE making all this stuff. So GE just told you with their new manual what your pinout on your old Magneblast is. So if you can't find it in the old manual, sometimes you might be able to get what the retrofit replacement is, and you'd be able to look up a manual that's a retrofit for it, and you'd be like, oh, well, here's the pinout because I didn't have it before. Cool. So this is the secondary disconnect. This is breaker side secondary disconnect. And then you're like, okay, well, what pins what, right? Well, what's neat is this is meant to be a retrofit. You're supposed to take the old circuit breaker out and put this one in. So the closed coil is still connected to the same pins. The trip coil is still connected to the same pins. The motor is still connected to the same pins. So you can actually just go through this drawing right here, and you can see here's your 52 motor. It's going to be on L, your secondary block, pin 1 to pin 8. Okay. And then this comes through over here, and you have pin 4 runs down as a common to pin 8. So your motor is pins 1 to 8. Over here, that's pins 1 to 8. If this is a DC circuit, make sure that you maintain polarity. It says right here in it, this is a little positive, hard to read, but I zoomed in for you, and this is negative down here at the bottom. Typically, that's how drawings are made. So you have your pin 1, pin 8, pin 1, pin 8, that'll start your motor charging. Pin 4, pin 8, pin 4, and pin 8. So 8's a common between the two circuits, and that'll get your closed coil. Now, what's not here is down here. You have to kind of look for it, okay? This is your trip coil, 52 TC. It's pins 9 and pin 10. So pins 9 right here and pin 10 right here. And that's your trip coil. All right. So hopefully that helps you guys. Like I said, this is a cool little trick to go ahead and find them. If you're trying to go through and you're trying to test your 52AB contacts, your spare auxiliary contacts, here's your pinout. Okay. And this is supposed to match the original Magneblast. So this should be the same block as the original Magneblast. So this is a really good trick to use when you're out there testing the field. Like, I don't know what the pinout for this one is. This is a really old breaker. Well, look up a retrofit manual and maybe you can get the control drawing from that one, right? Because it was supposed to be a direct replacement.